Okay, we're going to try this again. It's been a process today trying to get these lessons recorded, but this is lesson 3, solving single-step inequalities. So in this unit, we're going to be pulling in what you already know about equations, and the equations we're dealing with are very basic equations. So that part should be nice and easy for you, but now we're adding an inequality sign, meaning that there's going to be a range of answers, and there's people screaming outside. That's not me, I swear. Okay, so just a reminder that when you are solving basic equations, you're always looking for your variable and then doing the opposite to isolate it. So when we have x plus 3 equals 7, my variable is x, it's being added by 3, so I'm going to minus 3. Whatever I do on one side, I do the same to the other. So 7 minus 3, so x is 4. And just to check, 4 plus 3, yeah, it works. Okay, so if we had the inequality, x plus 3 must be greater than or equal to 7. Again, I'm going to isolate my variable by using opposite operations, so minus 3 on both sides. So x must be greater than or equal to 4. So when I go to the number line, I'm going to make 4. Some of you, when you made your number lines in your assignments, you're picking really bad scales, like you're putting your boundary point right at the end of your number line. Try not to do that. Try to put your boundary point somewhere near the middle of your number line. So we see a range of values that are included and values that aren't included. So my boundary point is 4. When I look at the inequality, it's a greater than or equal to. So that means the dot is going to be colored in. Remember, open dots, use these inequalities, closed dots. Okay, just a reminder, so boundary point is 4. X has to be bigger or greater than 4, so that means it's got to go this way. And so the way that we check is we pick a value that's bigger. So let's pick 6. So 6 plus 3 has to be bigger, so greater than or equal to 7. So 6 plus 3 is 9. 9 is greater than 7. So yes, our arrow is going the right direction. So in this case, there's a range of possible solutions. So 4 would be the lowest possible solution, and then anything larger than that are all acceptable values for x. Okay, looking at our next two, we have negative 5 equals x over 3. So we have an equation again. Our variable is x. It's being divided by 3. Opposite of divide by 3 is multiply by 3. So we get negative 15 equals x. Looking at the inequality, again, we're going to do the same thing. So if x is being divided by 3, we're going to times both sides by 3. So that means x must be less than negative 15, or negative 15 must be greater than x. Okay, so again, my boundary point, somewhere near the middle, negative 15, negative 14. Remember that when you are in the negatives, your number line looks like it's in reverse. So at my boundary point, I'm going to have an open circle because the inequality is not equal to. And x must be less than negative 15. So smaller than negative 15 is going to the left. So that means any of those values to the left of negative 15 are possible solutions. So if I picked, let's say, something else that divides by 3, let's say negative 21. So negative 5 must be greater than negative 21 divided by 3. Negative 21 divided by 3 is negative 7. And this is true. Negative 5 is greater than negative 7. Okay? Next example. Okay, so negative 2x equals 8. So negative 2 is being multiplied by x. We're going to divide both sides by negative 2. So that we get x equals negative 4. Now when we do the inequality, so we're going to go divide by negative 2. So x is less than or equal to negative 4. So put my boundary point at negative 4. Okay, and it's a closed dot at negative 4. And so x must be less than
Mr. B, counsel, if you're still in the building,
negative
come
4.
to the office. Mr. B. What's the office, please?
So then we're going to check our solution. So I'm going to go -2 times, let's pick -6. -2 times -6 should be less than or equal to 8. Negative times negative. Positive 12 is less than or equal to 8. That is not a true statement. 12 is not less than 8. 12 is greater than 8. So there's something we need to keep in mind here when we are dividing by a negative, which is really important. This is our first rule of inequalities. So this is an incorrect solution. And our first rule of inequality says that when you multiply or divide an inequality by a negative, you must flip the inequality sign. So a less than would become a greater than or equal to, greater than or equal to would become a less than or equal to. So the inequality sign is the direction it flips. And I'm going to show you a little bit why. If it still doesn't make sense to you, we can talk about it tomorrow. So just going back to our regular question, our original question, -2x. So I don't like that the x is negative. I'm going to make it positive by moving it to the other side. So add 2x. So now we get 0 is less than or equal to 8 plus 2x. Okay. Move the 8 over. So -8 is less than or equal to 2x. Now I can divide by 2. It's a positive. So we get -4. I'll pull this up a little bit. So then we get -4 is less than or equal to x. So that means that x has to be greater than -4. So actually that our arrow is going the other way. Okay? So that's one way that we can do it. So we can actually move x to the other side of the equation. The other way we can do it, and I know I haven't given you two space, or -2x. Okay? We can divide both sides by -2. So we're going to divide both sides by -2, and we're going to flip the inequality sign. So instead of less than or equal to, the inequality is going to flip to greater than or equal to -4. And either way, we get the same inequality, that x has to be greater than -4, or -4 has to be less than x. So now if we check it, let's pick, we'll pick -2. So -2 times -2 should be less than or equal to 8. Negative times a negative is positive, so +4 is less than or equal to 8. Now it's a true statement. I know there's a lot of work on this example, but I wanted you to see why the inequality sign has to flip when we divide by a negative. Okay, we're going to solve these examples, and then it says verify your solution by substituting two values. So I'll explain what I mean by that. So, looking at the first one, my variable is x. It is being subtracted by 1.6. So opposite of subtract 1.6 is add 1.6. Whatever we do on one side of an inequality, we do to the other. Notice that with subtraction, we do not flip the inequality sign. It's only with multiplication or division of a negative. So then x must be less than or equal to -4. So to check, let's pick when x, so we need an x value that is less than -4. So let's pick when x equals -5. So 5 minus 1.6 should be less than or equal to -5.6. 5 minus -5. There we go. So that gives us negative 6.6 is less than or equal to negative 5.6. Okay, and so that works. That's a true statement, but we need to substitute two values because we want to make sure that negative 4 is the right boundary point. So I'm going to pick I'm going to pick an x that is greater than negative 4. So I like to pick 0 when possible. Nice and easy. So 0 minus 1.6 should be less than or equal to negative 5.6. Negative 1.6 is less than or equal to negative 5.6. No, that's not a true statement. So looks like we have a good boundary point. So x is less than or equal to negative 4 appears to be a good solution. Okay, just slide it under there. Next one. Negative 2 times x is greater than or equal to 11. So we need to divide by a negative. Remember, when we divide by a negative, we are going to flip inequality. So then we get 1x is less than or equal to negative 5.5. If you don't like that, you could rearrange your inequality so that the x is positive by adding 2x. And then minus 11. And then divide by 2. So we're dividing by a positive, so we don't flip it. Either way, we get the same inequality. X has to be less than negative 5.5, or negative 5.5 has to be greater than x. I don't mind which way you prefer. The second way takes a little bit longer, but they're both proving the same point. So in order to prove that this works, we need to pick a value for x that is less than 5.5. Let's go 6. Negative 6. So negative 2 times negative 6 should be greater than or equal to 11. Negative times a negative gives us positive 12. That is true. Yay. And then we need to pick a value that shows that we have a good boundary point. So instead of negative 5.5, let's pick x equals negative 5. So then negative 2 times negative 5 is greater than or equal to 11. We get positive 10 is greater than or equal to 11. And then no, that is not true. So that appears to be a good boundary point. If we have something larger than negative 5.5, it doesn't work. If we have a value smaller than negative 5.5, it does work. Okay, last one. I know this is a bit longer video. A game store is offering a game on sale for $12.50, including the tax. So the tax is already in that price. Okay, you're not paying extra. Sean has his spending limit at $80. That's his limit, so he's not going to go over $80. How many games can he buy and stay within his limit? So he's buying many games. So let's let G represent the number of games. And each game is going to cost $12.50. So $12.50 times the number of games he buys. That needs to be less than or equal to $80. Okay, that's his spending limit. He can spend $80, but he can't go over it. And he can spend anything less than $80. So now we need to solve the inequality. So G is being multiplied by 12.5. So we need to divide by 12.5. It's not a negative that we're dividing by, so the inequality sign does not flip. And we get 6.4. So that means that he can buy 6.4 games. So that doesn't really make sense. So he could buy up to 6 games and would have some change. Okay, that means he could buy 5 games, 4 games, 3 games, 2 games, 1 game, anything up to 6 games, but he wouldn't have enough money for that 7th game. Okay, 15-minute video. I blame the interruptions. So, go through this. You have 2 days to work on these practice questions and ask questions in class. And yeah, that's it.